Hi and welcome. I was searching the internet and YouTube for tutorials on how to deploy a Keras model as a web service, and I really didn't find anything fairly straightforward, so I decided to make my own. I hope this saves you time and effort. In this project, we're going to expand on the Iris dataset project by deploying our Keras model through a Flask API. We'll then develop this website where a user can submit iris flower measurements and click the Predict button and get back the flower category. So let's get started. We're going to look at all the code required to deploy a machine learning model as a web service, but let's start with a summary. This graphic gives us a summary of how we can deploy a trained machine learning model as a web service API. This web page is index.html. When a user clicks the Predict button, the JavaScript code in index.js reads all the flower measurements from the input text boxes and sends them over the internet in JSON format to the predict.php file via an HTTP post operation using AJAX. In predict.php, we extract the measurement values and use curl to post the data to the Flask web server. The Flask web server receives the flower measurements and runs the Keras predict function on the data using the machine learning model iris_model.h5. The model returns the probabilities that the data belongs to each flower species. In flaskserver.py, the probabilities are JSON encoded and returned to the curl function, which is then returned to the AJAX function in index.js. In index.js, the JSON formatted probabilities are parsed and assigned to the inner HTML of a span to display on the web page. So let's take a look at the code. All the code is available at the GitHub link below. I won't go through all the HTML code, but rather point out the important parts that are required for this project. We need to reference our index.js file as it contains our JavaScript code to read the flower measurements and post the data. You also need jQuery for the AJAX functionality. The input text boxes are assigned these IDs: SL, SW, PL, and PW for sepal length, sepal width, petal length, and petal width. Also, they're assigned these default values, which are a setosis category. The Predict button runs the Predict function in the JavaScript file when it's clicked. The percentage of probability that the flowers belong to each class is displayed in these spans, which are assigned these IDs and are updated in the JavaScript file when the results are returned. In the index.js file, we get the values of the text inputs and assign them to the variables SL, SW, PL, and PW by using the element by ID function. Next, we get the HTML elements that will display the probabilities when the AJAX function is complete. The AJAX operation is the heart of the Predict function. Here we define the type of AJAX operation, in our case, a post operation, the URL that we want to post the data to. The data type will be a JSON format, and the actual JSON data, which is the label and the value. When the operation is complete, it will either be successful or error. If it's successful, we run this function. First, I like to write the server response to the console so we can see what's going on. And then we parse the JSON response so we get the individual values, and we display this in the console as well. This is really not necessary for the functionality of the website, but it helps in the development process. So for example, if we look at the console, we can see the server's response when we click the predict button. Here is the JSON response, and here are the parsed values. We then cast the text JSON probabilities to a float, multiply that value by 100 to convert it to a percentage, and display it to 1 decimal point. If the AJAX operation is not successful, we display the word error for the prediction. The JSON encoded flower measurements are posted to predict.php from the AJAX function in index.js. In predict.php, we retrieve the 4 flower measurements and assign them to the variables $SL, $SW, $PL, and $PW. We then create an array of labels and values and JSON encode this array so we can send it out to our Flask server. We also create a header with the content type of application/JSON. We next initialize our curl instance and specify the URL of the Flask server, the operation type, in our case a post operation, the header, and a few other settings. The most important is the field we want to post in our payload variable. We then execute our curl operation, and the values returned will be the JSON encoded prediction values that we echo back to the JavaScript function. Running on the server is our Flask web server. Now, I'm not an expert on Flask, and I think it has so much more capabilities than what I'm using. I'm just using the basics here. A few things that are important. First, when we run the Flask_server Python script, we print a message to the console showing that the model is loading. Then we load the model. Depending on the size of your model and the speed of your server, this may take 10 seconds or more. After the model is loaded, we start the Flask server. This is the IP address of your server, and the web server is listening on port 5000. Note that it is possible to load more than one model and use it in different app routes, which we're going to do in a future video. The app route that the PHP file points to is /iris/API, and it's expecting a post method. Here we get the posted JSON data and then parse the data and create a NumPy array, which we submit to the predict function on the iris model we loaded. ypred contains the predictions returned by the model, which we JSON encode and return to the PHP script. From there, as we've already covered, the PHP script echoes the predictions back to the JavaScript AJAX function, and if successful, the data is parsed and displayed on the web page. So there you have it. Flask makes it fairly easy to deploy a Keras model as a web service API. I hope you found this video useful. If you did, please subscribe, and if you think this video might be helpful to someone else, please share. And also, the code is available at the GitHub link below. If you have any questions, post them below and I'll try to answer them. And also, if there are any topics you'd like to see a video on, post that also in the comments below, and thanks for watching.